Hello everyone and welcome to another episode of Solving Advent of Code in Rust and Try to Learn Rust in Between. I'm Roberto and we have...
Luciano, hello.
Thank you everybody for joining along. If you never did Advent of Code is a coding challenge that is published every year around the Christmas period. We're working toward the last year one. There are 24 challenges and you can find them on adventofcode.com. We're publishing all our code on GitHub, on a repository. There is a link down below somewhere. We have a YouTube channel. We're publishing all our recordings there. You can find the link in the Twitch channel description. Last time we did episode
22.
22, right? Yes, thank you. Part 1 with brute force. Part 2, we started implementing the library that we needed. And now let's refresh what was the task with day 22. Do you want to share my...
Yes.
We have the readme. Okay, day 22, the reactor reboot. This is the usual story to gather the Santa Claus keys from this deep trench in the ocean. And we need to reboot the submarine reactor. So our input is a bunch of coordinates in a 3D space, X from something to something, Y from something to something, Z from something to something. Some of those are on, some of those are off. Part 1 request was, after you do all of this, but only between minus 50 and 50, how many voxels, how many cells are turned on? And we got our answer for part 1. Part 2 say, okay, now don't consider only the easy ones. Take in account also the big ones, so the full input that we have, not just the simple one. And what is at the end of all of this the number of turned on cubes in all of this? Obviously, part 2 was not doable with a brute force approach because numbers are too big. And so we thought of slicing the Z space in slices. For every slice, keep track of the rectangles that are formed by adding and removing rectangles to this surface, to these planes. And we started implementing it. To show you what is our complete input, you see that the complete input goes from minus 100,000 to 100,000 on all the 3 axes. And we have in dark blue the on cubes and in red the off one. So we have to take all of this and perform this operation of adding and removing. Obviously, we can't keep the single cube in memory because it will be too much. And so we have to find a better way of doing that. Now, do we want to also recap the Rust code?
Yes, let's switch screen. So, okay, that should be on. So what we did last time is we created a library, first of all, with all this kind of rectangle utility that Roberto described. So if we consider that we work on like different levels of height, then we are basically reducing the problem at a 2D problem rather than a 3D problem. So here we created this rectangle file or library, for lack of better words, in Rust, or subcrate, I have no idea what's the name, where basically we are trying to describe all the different structs and utilities that we want to use to be able to slice this bidimensional space. So let me show you that first. So this thing is called rectangle, and basically what we have is a point, which is just a combination of X and Y coordinates. Then we created a rectangle, which is basically 2 points, so the top left point and the bottom right point of a rectangle. And then we have an implementation that just easily allows us to create a new rectangle by just giving the 4 coordinates of these 2 points. And then we also have a vector of rectangles. Because we're going to be using this a lot, we created a type alias, rectangle list. And then we have all these utility functionalities. So diff is basically the utility that allows us to take a bunch of rectangles in a list and a bunch of other rectangles in a list. And
one list and one rectangle.
Sorry, yeah, you're right. One list and one rectangle, and basically figure out which ones overlap and try to make a diff. So basically, it's removing the new rectangle from the list, the existing list, if there is anything overlapping.
Yeah, it's cutting the rectangle list with the coordinates of the rectangle with P0 and P1. Cut, and then it keeps only the one that are not in rectangle, so it gives you back another list that is all the rectangles as before, plus some additional one, but removing the one that you had to remove.
Exactly. Then we have another utility function called cut, which is the one that is actually doing the cutting. So this time we have a rectangle list and a single point, and the idea is that basically if you have a rectangle and you put a point somewhere, you are basically slicing that rectangle into multiple parts depending on where the point falls. So if it falls outside, you leave the rectangle intact. If it falls in the center, you are basically creating 4 sub-rectangles.
Yeah.
If it falls somewhere in the borders, you are just slicing it in 2, right?
Yeah. Or even outside of the border, but between the 2 x of the rectangle, you slice it in twice, because the external rectangle can be bigger and covering it. So yeah.
And basically that's all we have. Oh yeah, then we also have another utility called isInside that allows us to say, given a rectangle and another rectangle, is the first rectangle inside the second?
There is the comment in 92. Is R0 inside R1? Yeah.
And then we also created some tests. And for instance, here you can see how the cut works. So basically, if you have a rectangle that goes from 0, 0 to 2, 2, if we cut at the point 1, 1, we should get these 4 rectangles here. And this test is proving that, at least for this particular case, our code works. Now that we have all of these utilities, we should be able to complete our solution. But let's recap very quickly what we did here in the main code. So in the main code, what we have is the idea of a command, which is basically representing our input. If we review very quickly our input, every line can be seen as a command. And it basically means the first part is on or off. And then we have a range of coordinates, which basically is a way to describe different types of cubes. So it's like all the cubes going from, on the x-axis 23 to 22. Is it one cube, right? Or is it multiple cubes?
What?
I don't remember.
Sorry?
So this particular instruction
is 1 cube.
Yeah, it's 1 cube where the x goes from minus 23 to 22, right? The y goes from minus 17 to 33, and the z goes from minus 1 to 44. And this basically means take the space and add this particular cube. When you see off, it basically means subtract that cube from the whatever other cubes exist in the current space. And you can imagine that this is like a sequence of steps. And at the end, we end up with a certain number of cubes that are on. So command describes every single line. So we basically parse it. We can use it to parse the input. Then command has another helper called incube, which allows us to, it's something that I think we used initially for part 1, just to make sure that we observe that smaller space and not all the entire space. And here, this is all our parsing code. And then we have part 1. So part 1, as we said, was basically just checking, creating a space. A space is just an hash set of
3D points.
3D points, where basically we are considering, as Roberto said, like voxels. So you can imagine that if we have a cube that is 3 by 3 by 3, we are going to be creating multiple subcubes, 9 for every face, basically, because we only create cubes of size 1 in this particular implementation. So this space, this is why we can represent this space with just a tuple of 3 sides, because that's basically the origin, and then you go 1, 1, 1 in every direction. Here we get all the commands, and we also filter all the commands that are in cube 50, meaning this is only the subspace that we were supposed to consider for part 1. And then basically what we do, we apply all the on and off instructions, because here by looking just at cubes of size 1, it's easier to kind of subtract or remove. We don't need to slice anything down. Now part 2 becomes more tricky, because having a kind of an unlimited space is not really unlimited, but it's like fairly
very big.
We cannot use this approach anymore, because we will end up with too many pixels. So we need to consider regions in a kind of a smarter way. And Roberto ideas, correct me if I'm going to explain this very badly, is basically to say, we create a first hash set of all the Z ranges. And this hash set contains all the places, if we just look at the Z space, all the places where we found cubes.
Yeah,
by just looking at all the
everywhere we can cut the Z space. Because if we add or we remove, is always to keep track that something can change there.
Yeah, so basically it's like creating an index on the Z space. So we don't need to look in the empty spaces in Z, basically.
Yeah.
And so it's a kind of a way to start to reduce the problem from a 3D problem to a 2D problem. Because as soon as we have kind of these slices of space, we don't need to look at the entire space, but only inside all the slices where we know we are going to find cubes. This one also gets sorted. And then what we do is we also create an hash map where we say
what is the thickness of every Z region.
And the key is where the Z region starts, right? So it's just like, say,
exactly.
if you go at the Z region position 2 and you have a thickness of 4, it means that you might have cubes from 2 to 6 basically in the Z space, right?
Yes, but nothing in the middle, because we never found a command that is referenced to a Z of 5. So it's impossible that between 2 and 6 there is something.
Perfect.
Then it's impossible that there is any change in between. So they will consider it as only one place.
Okay, then we do a sorting of all of that, and then we do table windows. So we look at the first and the second and the third and the fourth, and so on, right? And this is just to calculate all this thickness. So because at the first pass we only got the points, all the starting points, then we are just looking at the thickness by making a diff between a given point and the previous one, a given point and the previous one. And that is basically building this map where between 2 points we have something, everywhere else we don't have anything, then other 2 points we have something, then another empty space, and so on. So just by looking at this hash map, we are reducing the amount of points that we need to look for, because we know a slice that might contain something and slices that don't contain anything. Then what do we want to do? This is just a copy of the previous approach, but we know it's not going to work because now we are not using 1 by 1 by 1 cubes anymore. We are going to be indexing things as rectangles. So we need now to do something different, right?
Yeah. So we have the loop. We have the loop in 109. We start setting before the loop space. Our space is made of planes. Why I say space is in Copilot is suggesting space? Is he listening to us?
I don't know. Maybe it's as control of the microphone.
No, because in line 112 you have written space in the comment.
Yeah. So we have 2 people in the chat. So hello, Ian Biclet Verra. I hope I'm saying that correctly. And hello also Neft. What color theme am I using? Good question. I have no idea. So let's check. I think if I do Command P, I can do theme. Color theme.
Yeah, and what is that you use?
Kanagawa. So let's change to surprising eggplant.
Oh my god. Can you go back to Kanagawa, please?
Let's go back to Kanagawa.
Yes, thank you. I still need my eyes. Oh, okay. Thank you. And I was saying we need planes that are a map that goes from the Z of the plane to the rectangle list type that we defined in the rectangles RS.
So what do we call it?
They are planes because they are made of rectangles that are bidimensionals, and they are on the Z axis, so they are collection of planes.
Is it a Nash map or a Nash set?
Is a map between the K coordinate that is a nice size and the what's called the rectangle list.
Okay, can we do default now?
No, because probably rectangle list. But before
doing no, wait. I have to
import.
We need to import. We need to say use use rectangle.
Everything.
Now I think we should have that working. Perfect. Okay, cool. You were saying?
No, fine. No, because now we have to go through our list of inputs, all our Z, but we already have all the Z that we need. So we could initialize the map with all the Z that we have in Z ranges, or they are Z ranges, or the keys of Z thickness. I think are the same.
So we could be using Z ranges sorted.
Oh, sorted or unsorted. If we have to create for any element in there, we have to create an empty rectangle list inside the value with that value as a key. So,
okay.
Yeah, take the sorted because we can loop on top of that twice. Is a vector. Probably looping twice on top of Z ranges is more tricky.
So basically, what we can do is for
we can create a map. We can do map in line 110.
We can. You mean like iteratively rather than doing a default?
Yeah. Can we create?
I think we can do hash map from iter.
Okay, and we can use it as key and apply a default value.
And then,
or we can just do Z ranges sorted map.
We can do Z ranges.
Without using the from iter. Ah, no, you're right. Yes, Z range sorted.
Iter.
Yeah, map. Copilot
then
is suggesting
something crazy.
Then
So-
we will have a value that is our Z.
This is our
Yeah.
Z, yeah.
Yeah, and we have to return Z and as value an empty rectangle list.
So we
That
can do
is
Z.
something that-
How do we return it? Z, and then rectangle list. Actually, it can be.
Rectangle list new.
Do we have that?
Rectangle list is an alias. I don't know what you can do with an alias. Can you?
Let's see if that works.
Yeah, but yeah, an empty vector. I don't know if
Does that work?
no, he's complaining. What he's complaining about?
Okay, was looking for random state. What?
Random state.
Wait.
Eh?
What if we just say from? Is that gonna work? This function take. Oh, okay. Fair enough. So if we add
what he wants in the from typing turbo fishing or
what is the diff? Because this is definitely an iterator at this point.
Yeah, instead from what is taking.
So I found a struct. Expect struct collection hash map. Random state.
Let's not care about the random
What
state.
if we do this?
Okay, now Z is a reference, and we declare that the key is not a reference.
Okay, that might be
Do
it.
start,
So
start Z. Okay, now he's complaining.
Iter, probably we cannot use iter because it was moved when we did into iter here.
Okay.
So what we can do is that we can use Z thickness, right?
Yeah, but Z thickness is lacking the last element of the range sorted. And we also destroyed the Z ranges. If you scroll a little bit
What
up.
if we just do iter here?
Okay, so what is changing if we do iter there?
That here
that
we
have
need
to
an
do
asterisk.
a star there.
Now this should work.
Now can we use it?
Yeah, planes is there. Does it need to be mutable at this point that we populated it?
The values must be mutable because the values are vectors and we have to populate the vectors. I don't know, that mutable is just for the object itself, like in JavaScript or
Yes, I think you'll need to do get mute, but you might not be able to do it if this is not mute as well. So I'm going to leave it for now, and then
the values needs to be mutable.
Yeah,
for sure, because now they are empty and we have to put stuff in there.
But in order to mutate a value, you need to do get mute of that value, and I don't think you can do get mute into the planes object if it's not mutable as well. But
okay,
if that's not the case, I think this is still going to complain later, and we can remove it.
Perfect.
Okay, so what do we do next?
Now we have to go inside that looping 113 and say, now we are sure that we have all the planes already there. Oh my God, let me see what he's proposing. No, it's not that. We want for Z in Z range sorted iter. We can still use it.
Yeah, because we didn't destroy it.
Yeah, okay. For any Z that open a curly bracket. Okay, yeah. For every Z, if the Z is okay, I like the first line. I like the if.
So let me try to understand. So if Z range 0 is below or equal
basically is start Z between range Z0 and Z1, so is in our
yeah, is it but this is fully contained.
Yeah, it needs to be fully contained. Yeah, with the equals.
Okay.
Yeah, so that's perfect.
It cannot be like partially contained, right? Because otherwise the range would have been extended.
Yeah, the Z must be inside those two ranges. And it will be at least one, because we have our Z comes from the commands, so it will be there.
Yeah, and also we build the index in a way that it contains slices entirely, right? It doesn't contain partial cubes. If there was a partial cube, it would have been larger, right?
Yeah.
So that makes sense now. So
yeah, no, they contain what's inside. Yeah, I don't think.
Yeah, let's remove this.
Now, our plane indexed by Z, so planes get mute of Z.
So these will be the rectangles inside the Z
Those
plane.
will be the rectangle list in that plane Z.
Let's call it in plane. I don't know.
Those are rectangles.
Okay.
That are our
Z ranges.
It was already
Get mute. Oh, I didn't see.
No, is planes. Is planes. What is planes? Planes get mute Z.
Oh yeah, perfect.
And this is a mutable vector rectangle. Cool. Now we have to say that we have to call diff. We have to call diff with rectangles as first parameter, and the rectangle that is left. Okay, I like this also. I like
so
this.
This is creating a new rectangle.
This is our this is the rectangle that we have to subtract. So perfect, but probably not mutable. I mean, I don't think.
Oh yeah, we don't need to make it mutable.
I don't think it needs to be mutable. And now we do diff between rectangles and rectangle to subtract. Let's not care about
diffed.
Diffed, yeah. Is the new value of the hash map. That will
so we need to pass rectangles and rectangles to subtract, right?
Perfect, yeah. He's already also doing the reference of it. Cool. Nice.
Okay, now, and this is the new vec.
Is the new vector of rectangle. Now, if command on, so now we always subtract the rectangle. Always. But if he's on, we put it back. These we always do the diff to be sure that we don't put in two rectangles that overlap, because if we put on two rectangles that overlap, we will count the point twice, and that will make our result wrong.
Right. Okay. Then
so we always do the diff. Then if command on.
And by the way, this makes sense because our diff is also slicing things down. So if there is something partially overlapping, it will be sliced first, then it's removed, and then only added once rather than adding it on top of an existing one.
Yeah, because if we add on top of existing one and we do some bug that does that, we will count that twice and the number will not match in the end. Okay. Is diffed add? Because it's not rectangles, it's diffed.
Yes, this is what Copilot is saying.
Yeah. Diffed add or push. No, it's push. What is that? Diff is
a vector.
But it's not push.
Yeah.
You don't care if using the front, in the back.
And here, why is it complaining? Probably types. Let's see. Expected vector.
Instead... it must be mutable. Must be mutable because we are pushing to it. Diffed must be mutable. Let mute diffed.
Oh, yeah. But here is still complaining. Also here it's complaining. Why? Function new is private. Is it? Oh, yes, we never made it public. That was an easy one. Now, here, diff, why is it complaining? So, expected a structure, so a vector, standard vector, found mutable reference. Okay.
Let's not declare that as mutable on line 116.
Yeah, what if we just pass this?
I think he's complaining on the left side, not on the right side.
No.
No?
No, it's good.
But,
thank you for the follow in Outworld.
Now he's not complaining in line 125 that we... No, he's not complaining that we borrowed...
I don't know why, but it's not.
He's not complaining that we borrowed?
He might complain later if we do something else with this.
Fine for me. I mean, if he's not complaining the compiler, who am I to say something?
Yeah. I think the reason why we do this, let me review this for a second, is because we mutate the rectangle.
No, we don't.
No, we don't. So this could be a reference then.
Yeah, because we're also always using the reference. Well,
yeah,
let's
maybe
leave it like
maybe
this.
no, maybe
Yeah.
let's fix it, because I mean, we might need.
No, that still needs to be a reference because it's the point reference. It's not the rectangle reference.
Oh yeah, you're right. And this didn't break anything. Not even in our tests. I am surprised.
Do we test diff? Probably we forgot.
But because we tested, no, we only tested cut. So
we only tested cut.
Okay, so here
let's now it complains, and
now also, we need to pass a reference. Okay, that's what we want.
Okay. Now we have to put diffed inside the key of planes in Z. So planes of Z equal diffed.
After the if statement.
Yeah, after the if statement, obviously.
So planes get mute. No,
how do you replace? Overwrite it. Put
if we just do insert, should override it, right? And K is going to be Z.
Yeah, Z
right?
again.
And this is diffed.
Yeah. Complaining, obviously, because...
because I'm retarded.
Ah.
And also Z needs to be explicitly a value, not a
okay, because our key is... well, those are integers. It's not a big deal to do star on top of it. Now, after all of these, for command in command.
So wait a second. We have a question from WGAFA. I know what he's going to suggest. He's saying, what derives does rectangle have? And we don't have the copy type.
We don't have what?
The copy derive.
Right? Okay.
So yeah, we have clone debug partial equal. So if we put copy here, by the way, correct me, WGAF, if you want to go in a different direction. I am extrapolating from a previous comment you made in another live stream. So if we copy, because it needs to be copy also here in point. At this point, we don't need. Actually, wait, no, because here we are talking about Z, which is an I sides. So
yeah, do we need to copy rectangles? I'm not sure.
I don't think so.
Remove it.
So yeah, the point is this one. I was just figuring.
You are asking why he was not complaining, but we are never copying rectangles around. In theory, we are just passing them as reference and using the coordinates that they contain to create new rectangles. So I don't think we are copying them anyway.
Okay, let's remove this copy here if we don't need it, because it might be a little bit dangerous to unintentionally copy. At least we see where we need to clone.
Now, I was saying, after all of this loop, we will have a lot of planes with a lot of rectangles. We have to pack up everything. So for every plane, we have to compute the area of the rectangles of that plane.
Mm-hmm.
So we have to sum the difference between the coordinates multiplied the x coordinate multiplied the difference between the y coordinate to get the area of a rectangle. We have to sum all of them, and we have to do this for all the planes, and then multiply every area of the plane got multiplied by its thickness. Mm-hmm. So what is proposing there, Copilot?
Scroll a little bit. You think it's that smart? Let's see.
No, it's...
By the way, just to complement what Roberto just said, the reason why we need to do all of that is because the final output that we need to give is the number of points, 3D points, that are going to be on in the end. Here we are only reasoning in rectangles, and then we have this index on the Z coordinate, where basically we know that there are rectangles and we know the thickness of that Z range. So basically, we will need to calculate the number of points based on that information, rectangles and Z space.
No, Autopilot went, I don't know what was thinking. I think the only line good is the first 4, but it's not even an intermute, it's an iter.
Actually, we need to do this even outside this command, right?
Yeah, it must be outside.
Okay.
Yeah, after the 4. We have to initialize a return value to 0, that will be our accumulator.
Let me clean up all of this. So we need to initialize let
mute accumulator equal to 0.
Num points.
Oh yeah, is the return value, is the number of cubes, is the accumulator, is something. Yeah, I think it needs to be a big number. Okay, for Z rectangles in plane, cool. We get the thickness, cool. Number of cubes is rectangle area dot thickness. Makes sense. The only problem is that we don't have a dot area function in our rectangles, but we can add it, or do we have it?
I don't think we have it, but it makes sense to add it.
It's exactly what we have to do, just that we have to implement area.
I think somebody on GitHub has this solution. And
Yeah.
Copilot is just saving us the trouble
Really.
of searching and copy pasting. Okay, so pub fn area.
Ooh, do you know what we did wrong? We did something wrong, but absolute, yeah, it works. But before running, because now I think we will have a wrong result, we forgot that the coordinates in our commands are inclusive.
The coordinates in our
if it say from 2 to 2, it's not a cube of width 0, it's a cube of width 1.
Right.
So if you go back in the command loop, where we where we create the rectangle that then is used, there is a for command in commands 2. Yeah, there. Where line 120.
Does it need to be +1?
All the coordinates, yes, of the second point needs to be +1. Also, is that correct? No, also Copilot messed up the X with the Y.
Oh yeah, good.
His Y range is 0.
Oh my god, that would have been so painful.
The fact that we could have switched a lot of dot zero.
X,
and dot 1.
Wait.
Yeah,
this is .0 and this is
.1.
.1.
Yeah.
Okay, cool.
Yeah. Like the name of the variable, I mean. It's only that Copilot made
This is why you should never trust Copilot.
Yeah, never trust Copilot.
Or trust but verify.
Yeah, that's my point against Copilot. You can write code that is almost correct. Then find this can take hours.
Awesome. Okay. So
do we want to see how slow this is? Because remember that we can do a lot of optimizations here.
Also, I wonder if I use
is this working?
Yeah, let's see if this works, but I wonder if I use sides will fit there. Let's see how long it takes.
We have to go to a bigger one.
Straight away. Expect to start vec, but found mutable reference. Why didn't Rust Analyzer figure that out?
Is in the diff? We were a little bit.
There is an error. It's just that there is an underline. For some reason, we didn't
type mismatch, but it's not very talkative. Type mismatch. Cool.
Yeah, I think there is something weird there with. So it needs a reference, right?
I don't remember if it's a reference. Point 1 is not needed to be mutable, and probably needs a star there. And remove the mute 4 or 5 lines above. Go up.
Wait.
Remove the mutable in line 116. Yeah. And this is use the star in line 123.
Can you use the star? I think you can.
Let's go
wait, and change no, I don't know if you can. Let's see. I expect that there is a problem because then you're going to partially moving things out.
Okay, let's just do a reference. Keep the reference. We change diff, and also we don't use get mute anymore, but we use get.
If you use get,
can we get something from a map? Yeah.
You get back a reference to a vector of rectangle. So you get a reference to a vector list.
Yeah.
Is that what we want?
Remove the star? No, I think we want a vector, but it's not needed in reality. Go in diff and change that to a reference. I don't think we are. Then cut needs also to take a reference, but again, it's fine.
Cut needs to take a reference, yes.
And I think everything is fine.
No,
the push is complaining.
Expect struct rectangle found a reference. Okay, that should be easy.
But we need to declare that cop. Oh no, it's already cloned. Okay. There is also another line if you scroll down for the Y. We do the same. No, line 91 is fine.
Why this one 91? Is complain. 91 is fine.
Why? Because we are looping on something else. Yeah, cool.
Okay, so here rectangles needs to be a reference. So this test should work. Can we run this test with errors in the other file? No. Oh, wait.
No, we have an error in this file.
So this is in line 32.
We forgot to add some.
There.
Yeah, we have to do reference there.
Maybe that's why I was not complaining below. Okay, cannot move out or which is behind a shared reference. So what can we do here?
New rectangle, rectangle new with the coordinates that are in R. You want to clone? Okay.
Isn't it the same?
Yes. I think it's exactly the same.
Okay, is that enough? Cool.
Okay, let's go back to our part
Now,
2 point.
here, should have fixed everything. Okay, now we should be able to run this. Let's see how long it takes.
Yeah,
Ooh,
because
exploded very quickly. Option unwrap. Lib RS 135. So what do we have there? 135.
Please.
So here, when we do this get Z, it might be empty. How is that possible?
We are looping in the planes, and we don't have the thickness for a plane. We lack the thickness for a plane. Why we lack the thickness for a plane?
Do we, every time we loop here and we slice, do we need to update this Z index or not?
No. We compute them looping on top of command before, so it's already. Do you know what? Set thickness. Can you do? Probably we don't need to consider the missing key. Can you say give me 0 if it is missing in the thickness? What is unwrap or default? Cool. And we just go with 0. So it means this layer is no.
Maybe if we do our default, it's the same. No, because our reference doesn't have a default. Why? What's the error? Yeah. Can we do our reference to 0? Is that gonna work?
Try.
Cool. I didn't know you could do that.
Okay.
Okay, and not. I mean, how is that possible?
No, probably we have a bug and it will not work. It will give us a wrong result. We have to redo. No,
It's working. So
I don't know. I don't understand why the last layer. Okay, the last layer doesn't have a key in thickness, because if we go first with second, second with third, last with nothing, so it's just the one before the last with the last. But we still have planes in the Tartukin account in planes itself. Because you're right, planes is generated by. If you go where we create planes.
Wait a second. I'm just curious to see if we say Z. Right?
Yeah. What do you want to see?
I want to see which Z we don't have.
Is probably the last one. So,
right?
So we are sorting. It will be the biggest one. So something around 1000, 100,000, something like that.
Oh.
That nice. Now we have format that.
How did you format? Format?
Oh, Python is an F.
Work?
Do you need to import it?
Found a struct. Why? What is Z is just an eyesight.
No, you want a reference to a string, not a string. Try to put a reference in front of that double quote. No, in front of the double quote.
What if they want to do this? Oh, because Z. Okay, that's why.
Because it's giving you.
Okay, Clippy. What do you suggest that is better? Use expect call it by a function call. Can you auto-fix it for me?
Please show me Rust. You teach me Rust, Clippy.
For whatever reason, that's better. And another thing I want to print is
ret. Sorry.
Like last one. How do we do? Yes, exactly that. Thank you. So if we get the same value as a failure, we are confirming that we don't have the last one.
Yeah, at that point we can create the planes from.
Exactly, it's the last one. So we don't have 97 whatever, and this is the same number.
Nice. Fine. I mean.
By the way, I feel like debugging with console log now. Console log, but in Rust.
Nice. Do you know what? When we create, instead of doing that, just go with the get and wrap, and we fix it when we create the planes.
Here? Do you want to restore our default?
Yeah. No. Let's go with unwrap only. Let's try something else.
Oh, okay. You want to revert it here and fix it.
Yeah, and then go where we create planes. That is above line 110.
110, yes.
Yeah. Instead of using Z ranges sorted, use Z thickness, but only the keys.
Mm-hmm.
How
Well,
can you get
here
on?
we can just do this, I think. We ignore the value and just take the key. That should be the same, right?
Yeah,
But
we just need the key.
except we will have an extra item.
One less.
One. Oh yeah, that's true. We don't need. Yeah, we don't need to go over. Basically, before we were going over, we were not missing one. We were looking outside the last item. Cool,
Let's see if
makes sense.
now it works, which is also more correct. I mean, it was working also the other way. Now, obviously, it's a little bit slow, but it's working. So you can do a comment, in my opinion, just to
and it's not that slow if you think we are not in release mode. I think if you run the benchmarks, it will be much faster.
If you want numbers, Python was taking in pure Python 5.7 seconds. And with the Git, but you can try in release mode. I think you can do dash release when you do test or not.
Can you commit first?
Yeah. In Gitted mode, it was taking half a second, and with the GPU was taking. I didn't did this with the GPU. I did some optimization, and they went down to 0.24 seconds. And now
let's
we can
do a cargo bench here.
Yeah, then we can do some optimizations because there are stuff that we can improve.
Yeah, for instance, you mentioned in the previous episode that when you cut a rectangle, you might generate up to 9 rectangles.
Yeah, 8 because
but most of the times you don't need to keep all of them as individual squares or rectangles. You can merge the ones that are fully adjacent on one side.
Yeah, I have a picture if you want to show it to explain that.
Let me switch screen while we are running the benchmarks.
Oh, okay, yeah, we cut time enough this way.
Yeah, you are on with your screen.
Okay, these are basically all the ways you can cut a square with a rectangle with another rectangle. So here, with the current algorithm that we have, we would have 8 rectangles. Instead, you can also describe the space with only 4. Same here. I can show you how it is if we don't. What is it? If we don't stitch stuff back. Let me search for it. Okay, this is the stitching back of. After the diff, we are putting stuff back together with this piece of code. Now, if I run this, I think I need. No, I don't need anything. Yeah, I just need for it to run. Give me a second because without adding them back, you see, here we have 8, here we have 3, here we have 5, 3, and obviously because our algorithm is working on top of a rectangle list, this makes the rectangle list bigger and bigger and bigger. Instead, if we add this piece of code that is doing now doing this in Rust is interesting because here I have a Python list and I'm playing with the Python list. Doing this in Rust.
Yeah, we'll need to either create a new list or figure out how to mutate the list dynamically.
Yeah, here I'm obviously mutating the list in place because Python. See, now instead of having 8, I have as less as possible.
Awesome. Yeah, just to summarize, because I think there might have been an ads going on. What we are trying to do is on one side we run the benchmark in Rust and we're going to see the results in a second. But while doing that, we were discussing possible optimizations. And one of the optimizations that Roberto suggested last time is if you look at the screen here, you will see all the different possibilities when you basically slice a rectangle with another rectangle. And what Roberto is doing here is already, for instance, in the first case, the top left one, in reality, you will get 9 squares and then removing the one in the center, so you get 8. Yeah. But we don't need to retain 8 of them because we could join the ones on the side, for instance. Yeah. And then we only need to retain 4 of them, which reduce the amount of cardinality of things that.
Yeah, our rectangle list is a vector, so the vector is smaller. And when we do for rectangles, we loop less.
And that gave you a boost in the Python solution, right?
In the Python solution, I go from 5.7 seconds. That is, is below because I wrote this, then I wrote the solution. Yeah, from 5.7, we were going to 0. No, this is with the Git, but 0.47. Then there is another optimization, and we went down to 0.24. So yeah, this is making stuff faster.
Awesome.
But we have to implement this. I can explain you this small piece of code, then we try to do that with Rust. Okay, this is doing, I start with a pointer at the start of the vector. Okay, very C-like. Then, while my pointer is inside my list, this is the rectangle pointed by the pointer. This is the rectangle after the pointer. Also, the rectangles are sorted by
these are the rectangles that you got after the diff.
Yeah, after we do cut and we do in is exactly like the Rust one. If you take a look at the diff in Rust,
but I'm not sure we sort in Rust, do we?
No, we don't sort. The sort is needed to stitch them together. So we sort. I sort the list that comes. That is what I was about to return. I sort it. Then I go the first with the second. Is the second an extension vertically or horizontally of the second? Is the second an extension vertically or horizontally of the first? If the answer is yes, I put in a rectangle that goes from the top left of the first rectangle to the bottom right of the second rectangle, and I remove at this point the second rectangle because I'm overwriting the first one. I'm removing the second one.
Right. Okay.
Otherwise, I go to the next rectangle, that will be the second one, and I check the second one with the third one. And like this until my pointer is outside of my list, and my list is shrinking, because when I do this delete, my list is shrinking in place.
Yeah, and because you merge two rectangles into one.
Yeah, I do -1 because I can't compare the last rectangle with anything. I mean, I can't go last with something on the right because there is nothing on the right. So this is a little bit tricky if you ask me to do in Rust.
I wonder if we can use that retain functionality.
We have to change and retain, or just retain everything. Because if there are no touching rectangles, we just don't retain anything.
But also, I don't think it's not, I mean, it's probably not that hard, because if we have a mutable vector, right?
Oh, yeah, I'm muting the vector continuously, so we can try to implement the same exact stuff.
Yeah, but you're doing this stuff inside diff, right? So it's pretty isolated. The only thing that matters is at the end we produce a vec of rectangles.
Okay, do you want this code, or I can?
No, you can help me build it. Okay. I think I understand the high-level one.
Let's go back to Rust at this point in the diff, and let's make the diff probably smart. Also, let's look at the benchmark because.
Okay, so the benchmarks are over. So for part 1, we do 243 milliseconds.
That
part 2 is
solution.
More or less doubled, 486.
Yeah,
it's actually like quite precisely double, which is impressive.
It's double, but is computing a way bigger space. So it's going faster, way faster.
Yeah, it's going much faster, of course, because it's doing a lot more than part 1. So part 2 is definitely smarter implementation compared to part 1.
Now, let's see if applying this change in the diff, we can go faster.
Let's do that. And another thing that I'm going to suggest, if we have time, otherwise we'll do it next time, is that we can also reuse the same solution for part 1, right? For part 2, also in part 1, and see.
Yes.
This should get much shorter in time. If I'm.
It's true that between 50 and -50, we have an overhead of creating hash map, all those kind of stuff. We can see if it's faster or not. Yes.
Yeah, we can try to generalize that solution later because
we can do a part. We can redo part 1 with the solution from part 2. Yeah.
Okay, so what we wanted to do is in cut, right? In the cut function. In diff here. Okay.
Yeah, we do the cut and retain. Now we have to sort R. R is our retar. Yeah, we have to sort.
And is it just gonna sort? No, we need to sort by something.
Okay, sort by.
Sorting by the area.
No, we have to sort by X, then Y, then X2, then Y2, in this order.
Did we do that somewhere else? Didn't we do it for here in the?
Don't remember if.
No,
we are sorting there because those are integers, so yeah, they sort automatically.
I don't know why I remember that we sorted somewhere else.
It's another exercise. Try to search sort in all the. Try to search .sort in all the files.
Okay, now let's just do it here. Okay, so we get A and B.
There is not a sort by key. There is not a sort by key. That is probably smarter.
There is sort by key, yeah, and then.
And what it gives us a function. No, what is F?
F, I think it needs to be a function. Yeah, where
Perfect.
you get the
No, it was
object.
what. Look at a Copilot. Copilot was right. Yeah. Yeah. Perfect. Is enough.
Okay.
I think that one is enough. We could add to that tuple also RP1X and RP1Y to that tuple. The tuple on the RP1X and RP1. Yeah. So it's sorted by the top left and then also by the bottom right. What is complaining there?
That we don't need this reference there.
And then up there, the area is exploding.
What don't you like, Clippy? Tell me. Casting the result of an I sides abs to U sides.
It's not needed.
Why does it need to be U sides?
As Copilot.
Ooh, because the area needs to be U sides. So can you just do as U sides in the end?
But why the result of that abs is A sides?
Good question.
Because it's returning a self. But no, it makes no sense to return self for an abs. Look, fine, as U sides. Look, is beautiful. Let's go back. Let's go back to us. Now, do you want to try to do exactly what Python is doing with the pointer?
Yes. So
we declare a pointer to start from 0.
Mutable. Let I equal let mute.
Yeah, mutable because we have to increment it.
Yeah. Then we want to do a while
I is less than the length of R means
or
1.
Dot len
means 1.
I don't know what did it do, but let's see. Actually, I don't even want to see.
No, it's rubbish. It's doing rubbish, yeah.
Calm down, Copilot.
Okay, that A and B are fine. Oh my god. Try to keep everything. Try to keep everything. It's incredible. It's exactly what... No, it's not exactly because he messed it up again with coordinates, but it's almost what we want. So A is the first rectangle. B is the rectangle after that. The coordinate, if that I was if the x of the first rectangle, so is equal to the x.
Let's just call them or1 and or2, or 0 and or1.
Even A and B was fine, and now we have to remember. Okay, this is if R0x0 x P0x, okay, P0x is equal to R1 P0x, okay, if the x, okay, and
R0P1
is equal to R1 P0y. Okay, it was almost there. And that one is R0 P1x equal to R1 P1x. Okay. Now the new rectangle, and then there is also an OR here. All of this is an OR with another expression. So yeah. No, where are you going? All of it.
Yeah, right?
No, you open the curly bracket too early.
Oh,
the round bracket too early.
Sorry.
All of this. Okay, cool.
So we are checking.
We are checking if the two rectangles touch. This one is being.
Why are we comparing only 3 points and not 4?
This is one above the other.
Okay.
We are checking that you have two rectangles, one above the other. There is a common line. We are checking that that line matches.
Okay.
So why 3 of them? In theory, we could. Because we are checking that the y is the same and the two axes are matching. So to check a line, you have to check the line. You have to check the top line of a rectangle with the bottom line of the other rectangle to check if they are one on top of the other.
Okay.
So you have to check 3 couples of stuff, or they can be on the right because being sorted, they can only be on the top or on the right, on the bottom or on the right. Sorry.
Okay.
Here is okay. They have to map to your R0 P1x is equal to R1 P0x, and R0 P0y is equal to R1 P1y and R0 P0y is equal to R1 P0y. In that case, we have to take R0 P0y, R0 P0y, cool, R1 P1x, and R1 Py. So the last one is R1 Py1. Okay, yeah. Because it's the bottom, the top left of the first and the bottom right of the second. Okay, we have to remove I plus 1. If they are not touching, we have to just go on with our life.
Is this else correct?
Yeah. We go on only if they don't touch, because if there are 3 squares in a row, we are merging the first 2, then we are merging also the third one. So until we merge, we don't move the pointer.
Okay.
We move the pointer when there is nothing to merge.
Right.
And then we return R.
Cool. So that should be it.
Yeah, if it's working, yes, because otherwise we have to check line 41 and 42 because
now we don't have a diff test, right?
We go also because the diff test would have been to the right, because it would have been 8 elements. Now it's returning in theory 4.
Okay, let's see if this still works. It didn't
now
work.
Boom,
so we fucked up something. Attempt to subtract with overflow in rectangle line 38. What?
There is an empty rectangle. There is the case of an empty rectangle list. Do if add an if r.len is at least it must be at least 2. Yeah, it must be at least 2. It makes no sense if it's not 2. If r.len, because in Python it goes to -1, doesn't care. Here probably is complaining about usize going in negatives, because I is a usize.
Okay.
Okay, again, let's see if it's correct or not. Half of the time in this way. Let's run the benchmark.
Okay, let's run the bench.
In debug mode. With the benchmark, probably still half of the time, but let's see. And we also got all the coordinates logic correctly at the first try.
That's impressive. Well, thank you for suggesting all the right combination.
Yeah, so I had to map my way of writing to your way of writing, and it took a little bit of real-time mapping.
Okay, this might take a minute.
Okay. Another optimization that we could do, let me see if I have a second optimization in my Python code. Attendere prego, please wait.
Part 1 regressed, but this is just noise because we didn't change anything that is used in part 1.
In your laptop, obviously, the noise is huge while streaming.
Yep. So hopefully, my CPU is like 99% right now.
It's trying to start.
So hopefully the stream is not suffering.
Ooh, yes, there's another optimization.
Yeah, minus 58%.
Yeah,
so it's 199.
Now there is another optimization in the cut.
Okay. Well, let me commit this first.
Yeah.
Combining.
No, it's again in the diff. Sorry. It's again in the diff.
Okay, so what is the other optimization? Do you want to show your screen?
Yes, we can show your diff before. Show your current
Let me
diff.
revert. My current diff, I already committed.
In rectangle, your current diff.
Oh, diff function, sorry. I thought you meant the change.
No, the diff function, not the diff function. Your diff function is doing cut, retain, and then there is the sort that is the start of the optimization. Okay, remember this: cut, retain, and then the optimization. Let's switch to Python.
Okay, you're on.
Okay. Now, here I have a cut. Yes, the cut is working like yours. I'm just not. I had to. Cat is working on a list right now. We can do that in your cat because the Rust code is slightly different. Basically, there is a new function called the touch. There is we are still cutting a rectangle even if we don't need. If there is a rectangle here and another rectangle here, they are not touching, but their x is one x of one rectangle is inside x of the two axes of the other rectangle. We are still slicing this rectangle in two by this vertical line. And that is not needed. So we need to understand if the rectangles are touching, and then we cut only if they touch. When two rectangles touch, when coordinates. So basically, when the corner of one rectangle is inside the other rectangle, so we have 4 of those, because we have 4 checks to see if 4 corners of a rectangle are inside the other one, then if the 4 coordinates again are inside the other one, or if they overlap doing a cross, or if the second one that we have to cut is outside of the previous one. Cross this way or this way, obviously, because it can be crossed in 2 different ways. No, the overlap is not needed, because when you check if one of the 4 corners of this one is inside this one, they will be inside, because it's so this is
exactly the same.
Yeah, this is the horizontal one, and this is the vertical one. So applying this touch, when cutting, we can cut only if they touch. If they don't touch, we just put the square in the return. But your code, the Rust code, is slightly different from this one, so we have to do this inside the cut itself. Do you want to try this?
Yes, let's switch.
Yeah, I keep the Python code here handy, so we can.
Okay, so we want to do that inside the cut, right?
Yeah, I think the right point in our code is the cut.
Should we do an isTouch method as well?
Yes, probably is needed. For now, create an touch method that is always returning true.
Okay.
This can be private, to be honest. But probably also cat can be private. Are we calling cat from?
Probably not. We'll complain if it's needed. Yeah, so touch
is taking 2
rectangles, right?
2 rectangles, yes. Don't trust
for one. It returns a boolean.
Yeah, for now, just return true always. Now, where do we need to use this? Okay, in between line 60 and 61. So no, is the condition on line 61, to be honest.
We replace this one?
No, we keep that one, but we add also if touch and that. If R touches, but this is a point. This is why I changed the code, because cat is not taking 2 rectangles. Cat is taking a rectangle and a point. For this reason, I did that in the diff and not here. Yeah, we have to change. Oh my god, it's hard.
I'm not following anymore.
Yeah, here we need to be able to say touch. We need 2 rectangles.
And we don't have the other one.
A rectangle, but a point, not a rectangle. So, or we pass an additional parameter to cut, that is the rectangle the point was taken from.
Okay.
And that is R2. Okay, let's do this. Other additional parameter to cut, that is the rectangle, not rectangle, a rectangle of type rectangle. And then when we call cut from diff, yeah, here we do touch of R and the rectangle, and we put an end. If they touch, and that. And also in the if that is in line, if you scroll down a little bit, down. There is another if very similar in line 90. Yeah, same. If they touch, and that. Yeah, and R is touching the rectangle. Okay. Now, where we call cut, complaining? Who wants the reference? Okay. Now in diff, when we call cut,
yeah, we need to pass the other rectangle. Yeah,
you need to pass rectangle or reference to rectangle or rectangle. What do we have there? Yeah. Okay.
Oh, it's already a reference, yeah.
It's already a reference. Cool. Okay. Now the test must still be green, but no performance gain because touch is always returning true. But at least
here we need to also do.
We don't have a rectangle there. We just have a point.
Right. So we can fake a rectangle.
Yeah, we have to create a fake rectangle that is going from 1-1 to 2-2. I don't know. Yeah, that goes from 1-1 to 2-2, and we are fine. In theory, it should be working. Try. Nope. Why?
No, it's working. It's just giving us a few warnings.
Yeah, because we are not implementing touch. Because touch
yeah. Touch is.
And part 2 must still be working if you want to try also part 2. In theory, yeah, complaining about perfect. Okay. Now we have to do the hard part. The hard part is writing all the logic for. So the logic here is a corner of one rectangle is inside the other rectangle. So let's start with the coordinates of rectangle 1.
So we can do R1, X1, Y1.
Yeah.
X2, Y2. Oh,
yeah.
How close is that? R1 P0X or 1 P0 Y. Yeah.
Yeah, fine.
Correct. Cool. And then the same.
Perfect.
Did you call it X3?
Yeah. I think Copilot is already there.
Or 2 P0, or 2 P0Y, or 2 P1X, or 2. Yeah, I agree.
At this point, I will copy and paste you now the variables are called like in Python.
Can't we? Oh, we need to add parentheses there. Fair enough.
Now, give me a second. Give me 2 seconds. Give me 3 seconds. And now you know that I can. You got it? Did you get it?
Where did you send it?
What's up?
Okay, it's coming through. Give me a sec.
If you can you copy and paste from there, or do you
I think so. Give me a sec.
I don't know if our code. Oh my god, sorry, my cat wants to code a little bit too.
Ooh, yeah, everyone wants that.
Yeah, we have the pet
special guest. Oh my god, super slow. Cool. I think I'm getting close.
Copy and paste engineer failed. Okay, 69 and 72 are comments, but comments in Python are different. Line 69 and 72 you can remove.
So yes,
because those are comments. And Python can chain conditions, and I don't think Rust can. Also, Python is using and or and not double.
Oh my god! Yeah, this is gonna become much bigger in.
Yeah, it's just you just have to do.
Okay, we don't need. First of all, we don't need this
return. Yeah.
And all the or become.
Yeah, become double pipe, and all the end become double half. Now we have to add end because you will just after x3 you have to do and x3. Yeah, then it's fine. Then y3 you have to do and y3.
Yep.
And x4
and
you have to
everywhere.
Do and x4. Then you have x4. Then you have to do and y3. Yeah.
Oh my god! I cannot even type.
Then and x3.
X3 and here and y4.
Y4. Yeah, sorry. And x4. Yeah, it's very. Yeah, in Python you can change stuff. He's doing basically the same under the hood. He's exactly writing this.
Yeah, it's just a syntactic sugar, I guess.
Yeah, it's just a syntactic sugar to write the stuff. It's funny because sometimes it leads to error because if you change the right sequence of false, equal, true, different from false, you get out not what you are expecting. There are edge cases that are funny to debug.
Let's
because,
double check that I'm doing this correctly. But,
yeah, I'm looking. If there is something wrong, I will shout at you.
thank you. You can shout gently.
Yeah, I will shout gently at least. Okay. Good. Yeah, you just need to do that once in that line. Yeah, no, the other one are already fine. Oh, fine. Only once. And then in line
This
71.
one, right?
Yeah, that is the last one.
Ah,
4.
oh my god, the auto thingy.
Oh, now I don't know what it's doing anymore because the formatting. If we did everything correctly,
It should
test,
still work and be faster.
Yeah, be faster and work.
Okay, let's run this test first.
Oh, right.
That's still working and it's fast enough.
Yeah. Then part 2 now is at
Ooh,
a little bit faster again, even
162. Let's run the benchmark.
Yeah. Yes, now the benchmark are at 199 milliseconds, 58% faster than the first implementation. Now we wait a little bit. Just a funny story.
We have Tony in the chat. Sorry, I didn't see the message. Hello, Tony. How are you?
Hello.
Glad to see you here.
Just a funny story. I implemented the same as the slicing of planes with cubes. So every time you have a cube, you can subtract a cube. You can get out 26 cubes, and then I stick them together. So in the end, you can have only 6 cubes out of every cut of cubes, and so on with all the optimization that they are touching. Everything, but in 3 dimension instead of doing the trick of the Z planes, and it's slower. The result is still correct, but it's slower.
Okay, I think because the Z planes probably for the kind of input we have, it's a good.
It's not terribly slower because it's again instead of 0.24 second is 0.5, so is but it's still double the time. Even if the solution is more correct because it is the 3-dimensional one directly. I was expecting it to be faster, to be honest. But in the end, there are 6,400 cubes in the list of cubes because I don't keep planes. I just keep a list of cubes. And that list of cubes is 6,400 cubes. So they are a lot. And when you have to delete a cube, you have to check against all the other cubes. So every time that you loop on top of 1,000 of cubes to remove a cube.
Okay, this is for some reason slower. I suppose it might be noise from my machine.
Also because part 1 went up. Try to run it again.
But if you run it again, we need to compare with what? Well, which one was the previous one?
199 milliseconds was the
199, yes, you're correct.
Let's see if with Python is faster, and I'm doing the test on a Colab remote virtual machine, so more or less it's constant CPU because it's not my machine, so I'm not streaming with it and so on. So it's more a stable hardware, like to say. You see, part 1 went 51% faster. We did nothing.
Yeah.
153 is less than 199. Yeah.
Okay. Interesting.
It's even faster because we are checking a lot of numbers, but we are reducing the number of
cardinality.
Yeah, we are reducing the cardinality of our list in the planes.
Cool. So let's commit this. And the last thing that I want to do, hey, Tony Go, thank you for the subscription. The last thing I want to do, I was about to say, before getting distracted, is that we want to uniform solution 1 and solution 2 and see if part 1 also goes down significantly, right?
Okay.
Session using is touch to avoid unnecessary cuts. I was writing unnecessary cuts, but
there are no unnecessary cuts.
Exactly.
We always want cuts, a lot of cuts. So you want to make a function out of part 2, passing the commands to that. And then you want to use that in part 2, and in part 1, you will pass a reduced version of the commands that you are already filtering, by the way.
I suppose the only difference is going to be that in part 1, we do this filter.
Yeah.
Everything else can be the same.
In part 2, we are not doing that. So we have to make a function that accepts a commands list. But
pretty much, let's just call it fn solve, right? That takes a command list.
Command, yeah. What is command? A vector of command?
I forgot.
Pass a vector because we have to loop it twice. So a vector is probably easier to loop twice. What do you think?
I think so.
and nothing else, a vector of command.
And it returns a U size.
A U size. We fit in a U size, luckily.
So what we want to do is copy paste all of this.
Yeah, don't take a command and commands U. We have to. Those are parameters that are passed to the function.
Well, oh yeah.
We keep the parsing in part 1 and part 2. The parsing.
But here we need to copy everything from here, basically.
Yeah,
right?
from line 100 to the end.
To here.
Yeah.
If we go here in solve, we basically copy paste all of this. And of course, it's going to say what the hell is command 2. But at this point, we should be able to just say commands again. Should we?
Yeah, dot iter. Do we have to iter on top of that? No? Why? Because in line 70 you are consuming the vector.
Okay, so let's just do this. And we just say let
you can't do iter in line. Can't you do iter on line 72? And also iter in line 88?
In line 72, which is not 24, right?
72. Commands not iter.
Isn't that the default? Okay.
And then you can do the same there with one R. And isn't he fine with it?
Yeah, it is. So. Cool.
Perfect. Now Alp complaining because we don't use it. Nice. Don't worry. We'll do that.
Okay, so now for part 2, let's start with part 2.
Yeah.
Basically, the only thing we want to do is to get rid of all of that and return solve commands.
Commands needs to collect a vector because now is a iterator.
Right, and it's a vec of command, and we need to collect. Perfect. Fine. And now part 1. Let's see if part 2 still works. First.
I mean, we did nothing in theory.
Cool, still works. Yeah. I don't trust myself doing
this kind of refactoring. No, they are asking if Advent of Code already started. No, this is last year one. This is exercise 22.
Yeah, we have been very slow in.
Yeah, it's important to end last year before the next one. Come on.
Okay, so here what we want to do is again accumulate all the commands.
Yes, a vector.
Of command and .filter .collect. And at this point, we can just call solve. That should be it. Let's see.
Let's see if it works.
Nice.
Yeah. Okay. Now benchmark.
Benchmark, which we have here.
What was part 1? Scroll a little bit up. Oh, well, it will tell us.
It was 248. Let's see.
Yeah. So slower than part 2. Because it was a brute force approach for part 1. Now it is the smart approach.
Yeah, it's nanoseconds now.
Yeah, now is those are microseconds.
Okay.
Nanosecond is very small. Those are microseconds. So yeah, alpha millisecond minus 99%.
Awesome.
Yeah, it's faster. Good. I think it's faster.
Perfect. So
yeah, and there was a little bit of noise, but not that much. And we are not cloning a lot in the end in this solution, so it's quite clean this time.
Okay, so we are going to push all of this in the repository, and I think this is probably all we have for today.
Yeah, let's wrap it up. You can find the recording on YouTube. The link is in Twitch on the About session. If you're watching this in the future on YouTube, we do live streaming on Twitch every Monday, 5 p.m. Dublin time. Make sure to check the Twitch link in the YouTube description. Give us a follow, thumbs up, everything, money, whatever you want. Feel free to leave comment, open PRs against our repository. The repository is at this banner. The probably is on the screen. Everything is well accepted. We are trying to learn Rust. Don't expect our solution to be the most idiomatic or cleanest one, even if they are getting better. So if you know better ways of doing stuff, please tell us. Open pull request. Thank you for all the collaboration on the chat, all the links. And are we going to rate somebody?
Oh yeah, good question. I'm totally unprepared for this.
So now I will just entertain everybody with, I don't know what, with my cat.
I think we're gonna skip the raid for today and just because I don't see anyone online. So we are just gonna look at the cat for a few more seconds. Move more to the right, I guess, or left.
Like this?
More in that direction. Yes. Now we can see the cat, which doesn't seem particularly happy.
No, he's just sleeping a lot. So. and leaving his fur on top of my microphone.
That's why your sound quality is so
Yeah,
good.
my sound quality is so muffled because of that.
All right. Thank you, everyone.
See you.
See you next week. Bye.
Bye.